Let's take a look at exercise 45 from section 4.5. We have a logistic growth function P of x that models the percentage. So P is the percentage of Americans who are X years old and have some coronary heart disease. Use this function to find the age at which the percentage of Americans who have some coronary heart disease is 13%. So we basically are given a P. So we're going to let P equal 13, and we're being asked to find X because X is the age. So we're being asked to find the age for which P is 13%. So I'm going to replace P with 13, and then my only unknown in the problem will be X, and I will be able to find this by solving this exponential equation. All right, so what I'm going to have to do is I'm going to multiply the entire equation by this denominator. So I'm going to multiply the left and the right side of the equation by 1 plus 271 e to the negative 0.122x. And obviously what that does on the right side is the denominator, which is the same as what I'm multiplying by, divides into that one time, leaving me with a 90 on the right side. On the left side, I get 13 times this expression. All right, now I'm simply going to distribute the 13. You'll notice I'm not going to do any preliminary calculations. I'm going to put all of this into my calculating device. The right side is still simply 90. And my goal here is to isolate the exponential. That's my goal. So I'm going to do that by subtracting 13 from both sides. So I now have 13 times the 271 times e to the negative 0.122x equals 73. I'm sorry, 77. All right, and remember my goal here is to isolate the exponential. That's my initial goal, is to isolate that exponential. So I'm going to do that by dividing by what the exponential is multiplied by. So I'm going to divide by 13 times 271 on both sides. So on the left side, the 13 in the denominator divides one time into 13 in the numerator, and the 271 in the denominator divides one time into the 271 in the numerator. So I now have e to the negative 0.122x equals 77 over 13 times 271. And now I'm going to use a natural logarithm. I'm going to apply ln, lowercase l, lowercase n, to e to the minus 0.122x. And since those two things were equal, their logarithm will also be equal. That's one of the properties of the logarithmic function. It's 1 to 1. The only way two outputs are equal is if the two inputs are equal. All right, so the natural log is this natural log, let's talk about this one specifically, is the exponent that I obtain when I apply negative 0.122x to e. So what is the exponent that you apply to e to get e to the negative 0.122x? Well, obviously that exponent is just 0.122x. So I've completely eliminated the exponential on the left by applying the logarithm. But whatever I do to that left side, I have to also do to the right side. And now all I need to do to solve for x is to divide by this coefficient, negative 1.22. Negative 0.122 is what I meant to say. I think I may have said something else. So I'm dividing by that on both sides of the equation. Now, if you know how to use your calculating device, you can enter this in one step without having to preliminarily do anything. And you're going to get an approximation. So I'm going to do that. So this is approximately, rounded to the nearest whole number, 31. And I'm sure that's what we were told, to round to the nearest integer. So rounded to the nearest whole, positive integers and 0 make up the whole number. So an integer, in this case, the integer I'm looking for is also a whole number. All right, so that is, now I want to just mention, when you enter this into your calculator, whatever kind of calculator you're using, in order to get the right response, it's very important that you use a parenthesis and you understand that 77 is not only being divided by 13, but it's also being divided by 271. So I not only have to parenthesize the input to this logarithm. Actually, I think you only need to do that, because that'll be some number, and then you're dividing it by negative 0.122. So that is the correct way to enter that in to a calculator. Another option, most people mess up because they'll enter this, 77. They may not have a parenthesis with the log if their calculator doesn't automatically start when you hit the log button, give you a parenthesis. So then they're going to be wrong on that count. But additionally, they can be wrong because they don't end the parenthesis. So you have to include a parenthesis here. So a lot of people will enter this like this, even if they have the parenthesis. And that's going to be wrong, because that puts the 271 in the numerator rather than in the denominator. Now, if you do want to enter the 13 times 17, that's fine, but you'll have to parenthesize that as well. To me, it's easier to just do a double division as I did in the beginning. All right, so you can play around with this and make sure you know how to utilize your calculator. All calculators work similarly. There are some differences, but if you understand functions, you can figure out the calculator you're using. One way to do so is to work with numbers where you know what the answer should be. and to test and make sure you get that answer. So this is how this problem would be worked. And in my math lab, I'm putting in 31 years old. So I would be filling a 31 into this box. So that 31 is my age. So for 31-year-olds, 13% of these have coronary heart disease.